Alright, welcome to Segments 101. We will be talking about two different situations when we're dealing with segments and their lengths. So let's review what a line segment is. So a line segment is the measurable part of a line that consists of 2 points, called the endpoints, and all the points between them. So if I have a line, okay, here's a line, I have 2 points on that line, X and Y. A segment would be just this space between it. So effectively, it'd be like getting rid of these arrows on the end and just ending it at X and Y. And that's what we're going to be looking at a lot of today, are different types of segments. So the first thing we're going to look at is what's called the segment addition postulate. And that states if you have 3 collinear points or 3 points on the same line, A, B, and C, and B is between A and C, then the length of AC is the sum of BC and AB. In other words, if I have this entire segment AC, his whole length is made up of the 2 parts AB and BC. So what does that look like if I'm doing geometry with this? Here's an example. Find the length of segment XY if X, Y, and Z are collinear and W is between X and Y. So here's our segment XY. And we can see that W is in between X and Y. The first thing we're going to do is write what's called a geometry statement. And this geometry statement is going to give our algebraic equation for us. So the geometry here, segment addition says XY equals the 2 smaller pieces added up, XW plus WY. And this is where the algebra comes in. So now XY, that's what we want to find. That's our unknown. So we give that a variable. In this case, I chose A equals XW. If I go to my XW segment, I can see he has a length of 3. 3 plus WY. That segment there has a length of 11 in the diagram. So A equals 14. Or in other words, XY equals 14. But we have to give a reason to this. So the whole reason we can write this and say it was segment addition. So our segment addition said the long entire segment is the sum of the 2 smaller pieces, or the 2 small ones added together. All right, let's see another problem. Find the length of segment HS. So here we're trying to find this length there. We will always start with a geometry statement. So our geometry statement is going to follow that segment addition. So the whole length, the entire long segment DS, equals the 2 smaller segments added together. We know this. We said our reason was segment addition. Okay. So because we have segment addition, we can write this statement out. Now we're just going to go through and plug in the values. So DF in this diagram is 59. DH is 23. And plus, okay, you could put a variable there if you choose, or you can just leave it as HS. Okay. So now when I go through and solve this, I want to get HS by itself. So I'm going to subtract 23 on each side. So HS would equal 36. So that's segment addition 101. But we have another thing we can look at with segments, and that deals with a midpoint. So a midpoint is a point on a segment that divides it exactly in half. So if I have my segment here, A, B, the midpoint M means that this half is the same as this half. And those little marks there mean congruent. So the left side is the same as the right side. Okay? And that's a really important thing to remember when we're doing problems that involve midpoints. So here we have S is a midpoint of BT. Stop right there. S is a midpoint. That means this side is the same as this side. So I'm going to mark those congruent. Find the length of BS if BT equals 52. So BT is 52. And it wants us to find the length of BS. This guy here. So this time when we write this out, our geometry, we could use our segment addition and say that BS plus ST equals BT. We could use our segment addition. We can also use this definition of midpoint. So if I use my definition of midpoint, we can say BT equals 2 BS. Because the left side is the same as the right side. So I just have two of those segments. And that would be our reason here. So our reason would be definition of midpoint. And then I'll go ahead and plug in all the values we have from our diagram. So BT is 52, and BS, we could put a variable, or you can write BS. And now you're going to solve. To solve this, we want to get BS by itself. So divide by 2 on each side. So that leaves us with BS equals 26. Okay, so here we have another problem that uses this word midpoint. Find the length of segment AD if K is a midpoint. Midpoint means both of these sides are congruent. So my geometry, if both sides are congruent, that means the entire length AD equals 2 KD. And that our reason then is definition of midpoint. Okay. So now I can go ahead and start plugging in some values. AD is what we don't know, and KD is 17. Notice how I used KD because KD has that value 17 on the diagram. AK does not have any labelings on its side of the diagram, so we don't want to use it. We want to make sure that we use the pieces that have a value attached to them. That's why we're using KD, because we can plug the 17 in. Now I go through, I do my multiplication. AD equals 34. Okay, now we're given problems where we need to draw the diagrams. you will often need to draw these diagrams on your own. Okay. So let's look here. Q is a midpoint of BN, of that segment. So the segment is BN. And Q is the midpoint, which means he's in the middle. So I'm going to put Q in there, and I'm going to mark the two sides congruent. Find the length of BQ if QN is 21. So label it 21, and we want to know BQ. Okay. Now this time with our geometry statement, we don't care about BN. Nowhere in the problem does it give me any values for BN. It wants to know a relationship between the left side and the right side, BQ and QN. So we know BQ equals QN because it divides it right in the middle. So BQ equals 21. And our reason here is the definition of midpoint. Okay. So you may see it in this case where we have a left side equals a right side. And you may not use the entire segment for a midpoint problem. And that's okay. You need to focus on what information do I have and what segment pieces am I looking for. And what relationship can I build between those two? The information I have and the information I'm looking for. Okay, here's another one we need to draw. A is the midpoint of segment BC. Start with our segment BC. A is the midpoint, so A goes in the middle. And because it's a midpoint, I'm going to label those congruent on the left and the right. Find the length of AC if BA equals x plus 7 and BC equals 64. Okay. And we're looking for this segment length there. Okay, what I want you to do is stop and pause the video for a minute and see if you can set up and write a geometry statement for this. Okay. Pause it for a moment, see if you can write this out yourselves. Okay, so here's what you may have done. You may have said that BC, the whole segment, is to BA. And that would be correct. My reason would be definition midpoint. Okay? Because the left side equals the right side. Now I'm going to go through and plug in all my values that I know. BC is 64 and BA is x plus 7. Solve for x. I'm going to first distribute my 2. Next, I'll subtract 14. And finally, I divide by 2. Okay. And at this point, we would normally say, oh, I'm done. I got to the end. But the problem wants the length of AC. So AC, all the way back at the beginning, is congruent to BA. AC equals BA. So AC equals x plus 7, which means 25 plus 7, and that would equal 32. That would be your final answer. Now, I said this was one thing you may have written. You may have also used the segment addition postulate, in which case you would have something that looks like this. The whole segment BC equals BA plus AC. And your reason would be segment addition. Okay. If you write two segments with a plus sign in there, you have to write segment addition for your reason. Because you are adding segments, segment addition. If you're multiplying by 2, that's going to be your midpoint definition. Or if you're just setting two small segments equal to each other. But in this case, we're adding them. So now we can say that BC is 64, BA is x plus 7, and then AC, in our diagram, we have those marked as congruent, so x plus 7 again. And now you can go ahead and solve for x. Combine my like terms. I'll subtract from each side and divide to get to x equals 25. But this again would be the same thing that we talked about earlier. We don't want to find x. We want to know the length of AC. So AC equals x plus 7. Plug in 25 for x because we just solved for that. And you still end up with AC equals 32. It's okay to have multiple ways to solve a problem. As long as you're mathematically correct and you have proper and sound logic and reasoning, you will still get to the same answer at the end. Okay, let's draw this problem out together. T, J, and H are collinear. That means they're on the same line. And H is between T and J. So that means H is somewhere in between them, okay? Not necessarily in the middle or anything, just somewhere on that line. Find the value of x if TH is 43, HJ is 2x minus 7, and TJ is 50. Again, I want you to pause this video and I want you to try this entire problem out on your own. So write your geometry and give me a reason for it. Hit pause, try the whole problem, solving for x. Go find that value of x. Alright, so you've given this an attempt. Let's see how we're doing. The geometry for this problem, since it does not say midpoint anywhere in here, we're going to be using segment addition. If it does not say midpoint, you cannot use the definition of midpoint. This will just be a basic segment addition problem. Segment addition says the entire long segment equals the two smaller segments added together. Now that I have my geometry written out, I can go plug the algebra in. So TJ is 50, TH is 43, and HJ 2x minus 7. Now we're just in algebra. We're just solving for x. So combine my like terms on the right side. 43 minus 7 is 36 plus 2x. Subtract 36 from each side. So 2x equals 14. And finally, I'm going to divide by 2 and find that x equals 7. So let's just sum up and wrap up our notes here. So make sure you pay attention to the difference of segment addition versus the definition of a midpoint. Segment addition has to have the plus sign in the middle of them. A midpoint is going to say midpoint in the problem. Always draw yourself a picture and label it. If there are congruent segments, mark those congruent. Put in the different expressions and length values into your picture. And then always write out your geometry statements and give the reason. Those geometry statements are going to be required, and they will also be giving you your algebraic expressions and equations, because all you'll do is take those segments and put your expressions right in there. And that's all we have for today's lesson.